Assalamu alaikum dear students. This is International Islamic University, Islamabad Schools, Sahiwal Campus. Science grade 6, lecture number 3, lesson number 12, motion and measurement of distances. Students, bring your science book, open it and write date and day properly. Listen to your teacher attentively and mark all the important points said by the teacher on your book. In this lecture, first we will discuss about the rest and motion. Rest. The movable objects which do not change their position with time and remain at the same place with respect to stationary objects are said to be at rest. So first we will discuss about the stationary objects. The position of some objects are fixed on the earth. So this fixed position of these objects is known as stationary state, and these objects are known as stationary objects. So the movable objects that do not move or that do not change their position and remain at the same place with respect to the stationary object is known as rest. For example, if we have a few examples of rest, it can include the table and the chair in your classroom. These are in the state of rest with respect to other stationary objects, and these are said to be at rest. We have other examples on the page number 124. For example, a book laying on a table, a television set in a room, and a ceiling fan, a car standing in a car park are also known as rest. Motion. Motion is defined as the change in the position of an object with time with respect to stationary object. If an object change its position with respect to the stationary object that is already present over here, so this is known as motion. The change of position of an object is known as position. For example, when things around us change their position from one place to another place with time, with respect to stationary object, we say that they execute motion. Thus, an object coming toward us is said to have a motion toward us, and one which goes away from us is said to have motion away from us. So if we have example of motion, when we walk, we undergo a motion because our position keeps on changing. When we are walking, our position keeps on changing, so we are said to be in state of motion with respect to the stationary objects, like buildings and roads. Buildings and roads are stationary objects. So if we discuss our state of motion or rest with respect to these stationary objects, so while we are walking, so we can be considered as in a state of motion, or we are executing motion. So on the page number 124, you have some of the examples. For example, a boy walking down the lane, a running dog, a flying bird, a speeding car. All these examples are of motion. The motion can also be defined as the change in the position of an object with time with respect to the stationary objects. So here we have some types of motion. There are three different types of motion. The first one is translatory motion. The second one is rotatory motion, and the third one is oscillatory or vibratory motion. Every change in the position of an object or a body is called as a motion. So depending on the way in which the position of a body changes, or the way they are changing their position, or the way they execute a motion, there can be classified into three different types that are discussed as translatory motion, rotatory motion, oscillatory or vibratory motion. So first we will discuss about the translatory motion. Such a motion in which every part of a body or object moves via any path in the same direction by equal distance at the same time. For example, a motion in which every part of a body or object moves any path in the same direction by the equal distance at the same time. The time is the same, distance is same, and the path that is adopted is also the same. So this type of motion is known as translatory motion. For example, the bus as a whole all along the path moves. So this is known as translatory motion. Moving vehicles like cars, buses and trains are known as translatory motion. If we take up the example of a car, so of a bus, the bus moves as a whole all along the path. So all the seats marked, for example, A, B, C and D, and all the wheels of the bus move in the same straight distance, in which distance the bus is moving. So in fact, every part of the bus move the same distance, so in the same direction at the same time. So in the same direction, same distance, and same time, this type of motion is known as translatory motion. There are two types of translatory motion. The first one is rectilinear motion and the second one is curvilinear motion. So first we will discuss about the rectilinear motion. Rectilinear motion is basically the motion of a body undergoing translational motion in a straight line. If the body is moving in a straight line at the same distance, same time, and same path is followed, but the motion is in a straight line, so this will be known as rectilinear motion. For example, the second one is curvilinear motion. Curvilinear motion is the motion of the body undergoing translational motion along a curved path. So if the body is moving in the same direction, same path, same time, and all the parts of the object are moving, but the motion is in the curved path, not in a straight path. The motion is executed in a curved path, so this is known as curvilinear motion. For example, if we take example of rectilinear motion, we can have moving vehicles like cars, buses, and trains. And the second one is the movement of the objects like utensils, tables, stones, bricks, etc. These are known as the translatory motions, and the sub type of motion as a rectilinear motion. And if we discuss about the curvilinear motion, we have the example, the movement of vehicles along a turn. A turn is basically a curved path, so it will be a curvilinear motion. And the second one is the movement of the vehicles along a zigzag path, so it is also a curved nature path, so this is also known as curvilinear motion. Okay students, on the page number 122, 125, you have to mark the lines from such a motion in which every part of a body or an object moves via any path in the same direction by an equal distance at the same time is called as translatory or translational motion. On the page number 126, you have to underline the definition of rectilinear motion as the motion of a body undergoing translational motion in a straight line is called as rectilinear motion. So below are examples that we have discussed. On the same page, below the examples of rectilinear motion, you have definition of curvilinear motion with examples. So you have to mark the definition of curvilinear motion on the page number 126. Motion of a body undergoing translational motion along a curved path is called curvilinear motion. So you have to mark these definitions and a few examples from here. The next one is rotatory motion. Such a motion in which different parts of an object move around a central fixed point or axis in a circular path with different radii, but the body as a whole does not move from one place to another place is known as rotatory motion. In this type of motion, we discuss about the movement of all the parts of an object or of a body around a fixed point or axis along a circular path, but the object as a whole does not move from one place to another place. So this is a type of rotatory motion. If we have example, for example, the motion of a ceiling fan, this is also known as the rotatory motion. So if we take up the example of the fan, so the fan itself does not change its position. It does not move from point A to B or any other point. It does not move as a whole. But the blades that are along with it, and these are the part of the fan, are moving along a fixed circular path or a fixed curved path and show the motion. They execute motion, and that type of motion is known as rotatory motion. So on the page number 126, on the second half of the page, you can have definition of rotatory or the circular motion. So you have to mark from such a motion in which different part of an object move around a central fixed point or axis in a circular path with different radii, but the body as a whole does not move from one place to another is called as rotatory or circular motion. So you have to mark these lines which I have said. So if we take example, for example, different hands of a clock also execute circular or rotatory motion, and during the circular or the rotatory motion, the distance of the various portions of the body or the objects remain the same from the central point or the axis of the rotation. They just move around the fixed or the central axis along which they are moving. For example, if we take another example of the rotating motion to let it more elaborate, if we tie a stone from a rope, you can see it also on the page number 126. A child is shown over here that is having a rope and a stone is tied with that rope. So he is moving that rope inward or in a circular path. So this type of motion is also known as the rotatory motion, because the stone tied with the rope is moved just in a circular path around a fixed central point. For example, the motion of a spinning wheel is also known as the rotatory motion. The next one is oscillatory motion. So such kind of motion in which a body moves back and forth about its mean position. If a mean position is set and the body moves back and forth, so this motion is known as oscillatory motion. Example, the movement of our hand while walking. While we are walking, the motion of our hand is also known as oscillatory motion. As we walk, our hands move back and forth. So this is known as oscillatory motion. So in the example of oscillatory motion, we can also have example of pendulum, clock. So on the page number 127, you have to mark these lines for the definition of oscillatory motion. Such a kind of motion in which a body moves back and forth about its mean position is called as oscillatory motion. In other words, an oscillatory motion is a to and fro motion of a body. For example, if we take up other examples to explain the oscillatory motion, these will be the movement of our hands while walking, the left right movement of a handheld fan can move from left to right again and again. So this is also known as oscillatory motion, because this motion is to and fro motion of the body or the hand fan. The movement of the branches of a tree. If we show the branch of the tree in a strong wind, they move back and forth. So this is also known as the oscillatory motion, and the movement of a swing is also known as best example of oscillatory motion. The next one is periodic motion. In some kind of motion, the object repeats its motion after a fixed interval of time. Basically, this type of motion is that in which objects its motion repeatedly after a fixed interval of time. So the repetition of the motion after a fixed interval of time, this is known as periodic motion. So if we take up the example for this, we can have a best example. The rotation of Earth around the sun is also known as the type of periodic motion. So let us take up the examples of periodic motion as the rotation of the Earth around the sun. The second one is the rotation of the moon and the Earth is also known as the periodic motion example. Our heartbeat is also a periodic motion after a fixed interval of time. The fourth one is the vibration of the string of a bow. So this is also known as the periodic motion. So on the page number 127, you can see a periodic motion of a pendulum from point A to B and B to A and then A to C and then again C to A. So this is the periodic motion that is shown by the pendulum. So this is also a best example of periodic motion. So from on the page number 127, you have to mark the lines starting from the periodic motion. In some kind of motion, the object repeats its motion after a fixed interval of time. Such motion is called as periodic motion. Some rotatory motions are periodic motions. So you have to mark these 4 lines from the paragraph of periodic motion on the page number 127 to have the definition, exact definition of periodic motion. So here we also have a subtopic, that combination of different type of motion. On the page number 128, you can see the combination of different type of motion. Here is basically the explanation of combination of different type of motion. For example, if we have a motion, the motion of the wheel of a vehicle, bicycle, moving from one place to another place, it undergoes both translational and rotational motion as well. So as I have discussed translation and rotational motion, you can have an idea about the movement of the vehicle or the bicycle in which it have a translation and rotational motion both. And the second one is the motion of a ball rolling on the ground, rectilinear and rotational motion both. So these are basically the combination of different type of motion in one object or in an object as a whole and in its parts. So we have another example over here, the movement of an object attached to the suspended spring. So it can be a translational and oscillatory motion both, as the object is attached to the suspended spring. So this can be the translational and oscillatory motion as well. So here on the page 128 you can have do you know Earth rotates around the sun and takes 365 days to complete the rotation around it. Earth spins around its own axis too and takes 24 hours to complete one rotation. So both these motions are periodic. So one object can also have like more than one type of motions, and the same object can have simultaneously one type of motion. So these are known as types of motion, or the combination of different types of motion. Okay students, so here we have discussed about all the types of the motion in detail with examples. So at the end of this lesson number 12, that is motion and measurement of distances, you can have a word file attached with the last lecture of this lesson. So you can have to solve all the questions by the help of that word file and write down them on your classwork notebooks. Okay students, this is end of the lesson. Allah Hafiz.